All right, welcome to my low-tech edition of these videos. So there's no slide deck or anything this time. I just went ahead and picked a problem that I thought addressed this topic pretty well. So topic 2.2 is about representing two categorical variables. And our learning objective, that's what the LO stands for, is to compare numerical and graphical representations for two categorical variables. So what we have here is some data about video gaming and grades. Okay. So just to give you some background, the data came from a survey of 14 to 18-year-olds in Connecticut schools, high schools. And I think it's mainly boys, right? So this data is only of boys. And so some of them played games, some of them didn't play video games. And then we have what kind of grades they get broken up into three categories: A's and B's, C's, and then D's and F's. Okay. So on an AP exam, if there's a question about a number, right? The table here, this is called a two-way table or a contingency table, right? Is a good place to go to answer questions about numbers, like how many boys played games and got C's, or how many boys didn't play games and had high grades, okay? Or how many boys played games overall, right? And that's something that's missing in the table, but it's quite easy to add. Okay? So generally when we have a two-way table or contingency table, I like to make sure that there's always the row totals at the end here and the column totals at the bottom here. And then I also like to have the grand total here. Okay, so I'm gonna add that information in. Okay, so we're gonna put total there, total there. That's not showing up too well, so we'll do it down here. Total. Okay, and then let's go ahead and start adding these things up. Okay, 736 plus 450 plus 193. Okay, so that's 1,379. Okay, 205 plus 144 plus 80. That's 429. Okay, 736 plus 205, okay, that's 941. 450 plus 144 is 594, and 193 plus 80 is 273. Okay, and the grand total, we can get that a number of ways. We can just add the two row totals to get the grand total. We can add the three column totals to get the grand total, or we can add the 6 individual counts in the table to get the grand total. Okay. So the quickest way is just to add the two row totals, since that would only be two values to sum. 1379 plus 429 is 1,808. So our two-way table, again, contains just the counts, the numbers. Okay. So any questions that we want to answer about numbers, we would refer to the table. Okay. However, if there's questions that want us to look at percentages, well, the table isn't going to help us because there aren't any percentages there, but we're going to go ahead and convert these counts to percentages. Okay. Or to use more technical terms, we're going to convert these frequencies into relative frequencies. Now, if I think about how this data was collected, right, it's really data about two subgroups of boys, okay? Boys who played games and boys who didn't play games. So to help me, I'm going to use some coloring here to distinguish between the two subgroups, right? So we have in green, okay, our first subgroup of boys, those who play games. And then we'll use some other color, maybe like orange. to distinguish the subgroup of boys who didn't play games. So now I'm looking at this table as if it contains data from two subgroups. All right, so let's figure out what percentage of the first subgroup falls into each of these grade categories, right? So we're just going to take these counts and divide by the row total. We'll do the same thing for the second subgroup, right? Take the 3 counts and divide by the row total. right? And that'll give us the percentage, right? The part of the whole. All right. So I think maybe I'll just do it right here. So 736 divided by 1379, okay? And I'll just round it 2 decimal places. So that's about 53%. Okay, so 0.53. Okay, 450 divided by 1379 is about 33%, 0.33. And then 193 divided by 1379 is about 14%. Okay. All right, so now I've converted the frequencies or counts into relative frequencies, which I'm just going to think of as percentages. I realize I probably should have been consistent with my colors. I should have done that in green, but too late now. All right, let's look at the other subgroup of boys and convert their counts into percentages. Okay, so let's move this up a little bit. 205 divided by 429, right? That's the subgroup total. It's about 48%. Okay, 144 divided by 429 is about 34%. And then 80 divided by 429 is, let's just call that 19%. Right. So if I want to compare these two subgroups of boys, right, I wouldn't want to do it with counts, right? That would be an unfair comparison, right? There's like, I don't know, more than 3 times as many boys in this subgroup than there are in this subgroup, right? So comparing counts would automatically just be unfair, okay? But by converting to percentages, that's going to allow us for a fair comparison because now everything's scaled to be out of 100%, right? So these 3 percentages would add up to 100, you know, give or take some rounding error. And then these 3 percentages would also add up to 100, you know, plus or minus like some rounding error. All right, so what sort of graphs can we make? Well, probably my recommended one would be called the segmented bar chart, which I think I touched on in an earlier video. So let's go ahead and construct one. So we're going to put the subgroups here on the bottom. So played games, and then never played games. And then here on the vertical axis, this is where we're going to record our percentages. So let's go 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, so 100%, 50%, and 0%. Okay, and let's label that percentage. So let's see, if we look at, well, we might as well just go ahead and draw a bar for each group. All right, and each bar is going to go to 100%. All right, it's almost as if we were going to do a pie chart, right? And you know, the circle of a pie chart already is 100%, and we divide it into slices. Well, we're going to take a bar whose length is 100% and divide it into segments, right? Divide it into 3 segments because we have 3 different grade categories. All right, so let's start off with the A's and B's, right? So we have 53% of the boys who played games got A's and B's. So let's color that. 53%, and 48% for the other subgroup of boys. Okay, and then I'll just put a little key over here. Pink is going to be A's and B's. Okay, and then let's go to another color. So I haven't used blue yet. Okay, so we need to tack on another 33%, right, for the boys who played games who got C's. So 53 plus 33 is going to take me up to what, 86%. So 50, 60, 70, 80, 86% would probably be about there. And then for the other subgroup of boys, it's another 34%. So we've already colored in 48% in pink, plus another 34 would be 70, 82. Right? So this should take me up to 82, 60, 70, 82, maybe about there. Okay, and then finally the remainder here that's not colored is obviously going to be representative of the last category of grades. So we'll just choose, I forgot to add to my key. So the blue segment represents boys who got C's, and then this is going to be 14%, and this is going to be 19%, and that's going to be our D's and F's. All right, so the statistical question that we might have asked about this data is, is there a relationship between playing video games and grades? And now that we're looking at this segmented bar chart, right, which is showing the percentages, it doesn't look like there's a whole lot of difference, right? The size of the pink segments are more or less the same. The size of the blue segments are about the same size. And the yellow segments, again, about the same size. If we were really forced to, we could say like, well, maybe boys who don't play games are, at slightly, are a little bit more likely to get D's and F's, right? And boys who played video games maybe are a tiny bit more likely to get A's and B's, right? This is maybe a little bit higher than that, but again, like the naked eye, it's really hard to tell because, at least from a foot back of looking at this paper, right, they look almost the same size, right? The difference is minute. Okay, so I would probably conclude that there's little to no association between playing video games and students' grades. All right, and then the evidence is just the fact that the percentages within each subgroup are more or less the same. Okay. So I think I've shown you the Staplet app before, but it's worth doing it again. If I can find it. Yeah, here it is. Because I think it does a great job of creating these graphs, and doing it by hand is okay, but technology makes things a lot simpler. So I've already typed in all the counts here. So we have gaming status, and we have the two subgroups of boys, and then we have the grade average, which we have 3 categories. And then I just hit begin analysis, okay? And automatically it takes me to the segmented bar, right? So what I just did by hand with my highlighters, this did in a matter of seconds, right? And again, you can see that, the differences are slight, okay? So boys who played games, had a slightly higher percentage of A's and B's, 53 versus 47 or 48, okay? The percentages were more or less the same as far as boys getting grades of C. It was 32.6 to 33.6, not a huge difference. And then it was 14% to 18% for D's and F's, okay? So not a whole lot of differences going on here. The other options we have, we can make a mosaic plot, which preserves the height of each of the colored segments, but the width is changing based on the size of the group, right? So you might recall that there were like almost 1,400 boys who had played games, and there were only about 400 boys who had never played games. So to kind of represent the fact that the subgroup sizes are different, we widen the bars of the bigger group. Okay. but the heights of the colored segments are the same, right? If I switch back, you can see that the green, orange segments are the same height in the segmented and in the mosaic. The other option is to make a side-by-side bar graph. So what all that does is it takes the three different colored segments here and then separates them, okay, and then just sits them all on the bottom of the axis here. All right, so that was it. I'll see you in a future video.